In the previous lecture, we were talking about hypergeometric probability distribution, and we solved few questions from that section. And today we are interested in learning the idea of Poisson probability distribution. So first of all, what is this Poisson probability distribution? Basically, the idea is that if the probability of success in some experiment is so small and the number of trials is so large, then we normally use Poisson probability distribution, and we prefer using this because it is, you can say, more convenient as compared to the binomial probability distribution. However, you have to see the situation before using the formula, that whether you would prefer using the binomial probability distribution formula or the Poisson probability distribution formula out of the given situations. So if you see the properties of the Poisson probability distribution, that are these: the random variable is the number of times some event occurs during a defined interval. Okay. Second property or characteristic is this: the probability of the event is proportional to the size of the interval. The intervals don't overlap and are independent. Fine. So independent events are there, because if events are dependent or outcomes are dependent, then we normally use hypergeometric probability distribution. But in case the independent events are there, then we use binomial probability distribution or the Poisson probability distribution. But what we have to remember is that the probability of success will be so small, and the number of trials will be so large in case of Poisson probability distribution. Let us have some example in which we are going to talk about Poisson probability distribution. Let us say there is a book, and definitely in some book, the chances of committing errors will be there, but in you can say in text, the grammatical mistakes, or you can say the spelling mistakes, the proportion of these mistakes would be so small. Let us say if you're talking about spelling mistakes, so if there are you can say 1,000 words, so all could be wrong, but in fact what happens, few words are there with spellings that are not correct. So out of 1,000, let us say if only two words are there with incorrect spellings, then you can say 2 divided by 1,000. This will be the probability of success, and this will be so small. So out of 1,000, only you can say 2 errors are there. So small probability of success in this case. And similar situations, if you confront with, you will use this formula that is written over there in front of you: probability of x, mu power x, e power minus mu divided by x factorial. So now let us see what these notations explains. Mu is the mean number of occurrences or successes in a particular interval. Okay, so if you are going to conduct some experiments, so number of successes, and if you find out the average for those successes, that is mu, mean, average. Then E is there. You are familiar with this E. This is a constant, and its value is 2.71828. Then comes X, the number of occurrences, successes in some experiment. Then probability of X is the probability for a specified value of X. Okay. So this is the formula that you have to remember whenever you are interested in solving some problem with regard to Poisson probability distribution. Then there comes mean of Poisson distribution. The mean of Poisson distribution is basically, in your book, it is written as mu is equal to n pi. I'm going to write it as mu is equal to np, as I'm saying that small p is the probability of success. So better would be if you use this, because this pi we will use later on in the upcoming chapters when we will talk about population proportion. So normally we use this pi sign for population proportion. So better would be if you use small p for the probability of success in this case. And in this case, the variance is also equal to mu. So that is also equal to NP. In this case, that we are talking about probability, Poisson probability distribution, the average is equal to variance in this case. Right? So now let us try solving a few questions from your book. So you can read this statement over here. The variance of the Poisson is equal to its mean. Okay. So if, for example, the probability that a check cashed by a bank will bounce is 0.0003. So you can see that the probability of success is so small. And 10,000 checks are cashed. The mean and the variance for the number of bad checks or bounced checks is 3. And how you will calculate this? Simply, you will multiply n with p. So n is 10,000 and p is given 0.0003. So the answer is 3. So this is your mean average. Okay, mu, the value for mu. So now there are several examples. Let us first of all see the solved examples that are in your book. Example. Budget Airlines is a seasonal airline that operates flights from Myrtle Beach, South Carolina, to various cities in the Northeast. The destinations include Boston, Pittsburgh, Buffalo, and both LaGuardia and JFK airports in New York City. Recently, so this is the story. You don't have to concentrate so much upon this story. Basically, you are interested in figures. So recently, Budget has been concerned about the number of lost bags. And Poston from the analytics department was asked to study the issue. So this is some lady who has been asked to study this issue. She randomly selects a sample of 500 flights and found that a total of 20 bags were lost on the sampled flights. So this is the situation, and what is required? Show that this situation follows the Poisson distribution. What is the mean number of bags lost per flight? And what is the likelihood that no bags are lost on a flight? What is the probability at least one bag is lost? So this is the situation. And now you are interested in, first of all, finding out you have to confirm that this situation is a Poisson distribution situation. So you can see that out of 500 flights, only 20 flights were there when a bag lost. Okay, so 20 divided by 500, if you see, 20 divided by 500. So this will be the probability of success in this case. What will be your mu in this case? 20. These are the number of bags that lost in 500 flights. In 500 flights means divide by 500. So when you will solve it, you would have, what is the answer? If you have calculator with you. If you have your calculator with you, just give me the answer.
0.04.
0.04. 0.04. So this is your mean. Right? So you can say that on average, 0.04 bags lost in 500 flights. Then what is the mean number of bags lost per flight? So this is that. So answering this question, you can say that probability of success is so small, it is 0.04. And the number of total flights is 500. That is so large as compared to probability of success. So therefore, this is a distribution that we call Poisson distribution. Okay. So what is the mean for this? What is the mean? So you can see over here, mu is equal to 0.04. Mu is equal to 0.04. NP. What is P? See, what is N? N is 500. N is 500. And what is P?
Point
Probability
zero
of
four.
success.
0.04.
So what is the answer?
20, sir.
Okay, 20. So this is that 20, this 20. Okay. So how will you find out the average? 20 divided by 500. So this is 0.04. So now you will use this 0.04 in the formula to find out different probabilities. Okay. So let us solve this. What will be the probability that the question is, what is the likelihood or what is the probability that no bags are lost on a flight? No bags are lost on a flight. So probability of x is equal to 0. You can also write it as x is equal to 0. Although in your book it is equal to 0. So you can write it down as x is equal to 0. What this means? No bags are lost on a flight. So now the formula is mu power x. What is mu? 0.04. And the power of 4 will be mu power x. So x is given, small x is given, it is 0. And then e, and e raised to the power minus mu. So minus mu means 0.04. And then you will divide it with x factorial. So x is 0, so 0 factorial will be there. So 0 factorial is equal to 1. So therefore, you can solve it. This term will become equal to 1. This term will become equal to 1. And you simply have to have the minus 0.04th power of e. So you can take it. Yes, what is the answer?
0.9607.
0.960 and 7, and in your book it is 8. So when you will round it off, it will become equal to this. The next question is, what is the probability that at least one bag is lost? At least one bag is lost. And I have explained in my previous lectures that whenever you are interested in finding the at least situation, you will use this sign, greater than or equal to. So at least one bag is lost. What is the probability for this? So now you can see that if you are interested in solving this, there are two strategies. One strategy is this, that you take into your account probability of x is equal to 2 and then go onward, and there will be an infinite situation. So that is difficult to use. And the better strategy in this case will be that if you use the complement rule, 1 minus probability of x less than 1. This is the third possibility that you can take into your account. So now 1 minus probability of x is equal to 0, because we know that x less than 0 means there will be only one probability, and that will equal x is equal to 0, because 0 is less than 1. So 1 will not be there. So you will use this route, this strategy, to find out this probability. And now you can see that probability of x is equal to 0 we have already found. So you will use this value here, and the answer will be there. So 1 minus 0.9608. So you can solve it. See what is the answer.
.0392.
Point 0.0392. This is the answer. Okay. And similarly, if you are interested in finding out different frequencies, different probabilities, let us say what is the probability that one bag is lost, or two bag is lost, or three bags are lost, and so many probabilities up to 20 you can find out. Okay, so you will simply give the value to the formula. Let us say if there is a question that what is the probability that exactly four bags are lost. So how will you use that? Let me solve that situation. Come over here. And now we are interested in finding out what is the probability that exactly three bags lost. So x will equal 3. And now you will use the Poisson probability distribution formula, and that is mu power x. So you have found the value for mu, that is 0.04. You will take power for this equal to 3 because you are interested in exactly 3. So we'll take third power, and then uh, e power minus mu. So e is a constant number, and you will simply take the power for e, this, and you will divide it with 3 factorial. So what will be the answer? Exactly 3 bags are lost in 500 flights. What is the answer? Yes, quickly.
Sir, 0.0102.
0.0102. So in this way, there could be several examples. Okay, and if you are interested or if you are required to write down the probability distribution for this given situation, so then you will take into your account all the values. You will start from probability of x is equal to 0. You will make a table, and you write down that this is the number of bags lost. For example, 0. It is quite possible that no bag lost. Then 1, 2, 3 up to 20. So you will write down the table, and then you will make the probabilities as this table is there. Successes. So successes in this case, let us say this is 0. 0 means no bag lost. And then you will go onward, and it is just, you can say, a small table, but in fact, as the number of successes in this case are up to 20, so this column will move onward up to 20. Okay, and in this way you will write down the probabilities. So for each you can find out, as we have found for 0 and for 3, so you can also find out for the other events. Okay, so what is the probability for 3? 0.0102. And what is over there?
Sir, raised to power 10 minus
So
3.
you have to give
The
me
whole
that answer. Also, you didn't give me the complete answer. This is not the probability. Yes, give me the complete answer.
point, I guess it's star 0.
Point
Star 0.
0000.
10248.
102. So this is the answer. So in fact, what is the answer in your calculator? Exactly that answer. That is with raised to the power 10 minus.
3.
Yes. So what is that answer exactly?
Point zero zero zero
No, no,
zero.
no, no. Don't tell me in form of 0.000. Give me in the form of 1.02 multiplied by 10 raised to the power
सर ये -3 है.
minus 3.
Yes.
Okay. 1.02.
No sir,
0.
0.012.
0.02.
12.
0.12.
That's 0.0102.
0.0102. 0, 1, 0, 2. Multiply by 10 raised to the power minus 3. Is it?
Yes, sir.
Okay, so this is I'm just solving for those students who are unable to convert this into this form, who are unable to convert this figure into this figure. So what you have to do, you have to see that this is minus 3. Okay, so you will write down, first of all, for one value there will be, we write down point. So this point is for first value, and then 0, 0, and 0. Okay, and then uh, this 0. So I mean, for first value that you are going to subtract from this 1, this point is there. So now 2 are remaining. So for 1 this is 0. For second value this is 0. Okay, okay, then this 0 comes. Okay, and then this 0 comes, and then 1, 0, 2. So your calculator can also give you this value directly. Okay, so therefore this is the answer. And if you see this in this table, four zeros are there. And similarly for the number of, when there are number of successes equal to 4, 5, 6, 7. So these probabilities are almost same. So small probabilities. Okay, so this is the situation that normally occurs in the Poisson probability distribution when we take into account the number of successes, more and more number of successes, the probability becomes smaller and smaller. Okay, so this is the Poisson probability distribution, and we can write it in this way. And remember that if the probability of success is so small, and the sample size or the number of trials is so large, so this Poisson probability distribution in that situation approximates binomial probability distribution. Okay, so you can say that this is an approximation of binomial probability distribution in these situations when probability of success is so small and the number of trials or the sample size is so large. Okay, so there is another situation. Yes, for the same question, this is a table that you can use to write down the probabilities. Okay, as we used a table in case of binomial probabilities distribution, there is another table in your book that is regarding Poisson probability distribution, and this is a short form or a glimpse from that table. So you can see over here that if you are interested in taking into your account the average value equal to zero point 0.4, sorry, zero point 0.04. What was the average value? 0.04. This is not over. Let me go to the table. Yes, these are the tables. Come over here. This is the binomial probability distribution table. Binomial Poisson. This is Poisson. And if you see x is equal to 20 in our case, so you will come over here. This is 20. And then you will see that what is the probability of, what is mu. So what was mu in this case? So mu was 0.04. The value for that mu is not given in this table. So you could not find that. But if the value of mu is equal to zero point 0.4, then you are able to find out the probability. Okay. So therefore you will take help of your calculator. Therefore you will take help of your calculator in this case. Or Excel may help. Now let us solve some other questions from your book. This is another example, so you can take into your account this example. I'm leaving it to you. Simply, you will solve it, and it is similar to the previous question. Okay, as you can see that this is the case when at least situation is there. So now come to, and this is another table that explains that as the sample size is large, you can see over here, the Poisson distribution is always positively skewed and random. Variable has no specific upper limit. In lost bags example solution, the Poisson distribution with 0.04 is highly skewed. Okay, so I mean, if 0.04 is the average, then highly skewed distribution will be there. And as the average will go on increase, the distribution will become normal. You are familiar with this. This is the normal distribution. And you can see that in this case, mu is equal to 6. But in this case, it is, you can see it is positively skewed, and mu is equal to 2 in this case. So mu has reduced, and the normality of the distribution has been disturbed. And similarly, in this case, mu has further reduced, and you can see that this distribution is not normal at all. So as we will increase the value for mean or average, the distribution, the Poisson distribution will become more normal. Now let us try solving this self-review. From actuary tables, Washington Insurance Company determined the likelihood that a man age 25 will die within the next year is 0.0002. If Washington Insurance sells 4,000 policies to 25 years old men this year, what is the probability they will pay on exactly one policy? So you can see from here that you will use the Poisson probability distribution formula. Why? Because the probability of success in this case is 0.0002. So in this case, the probability of success is, you can say, is the number of people who die. Okay, this is the probability for the death of the people who are of age 25. Okay, and this insurance company is going to sell 4,000 policies this year to the people who are of 25 years of age. So what is the probability that they will pay on exactly one policy? Definitely on exactly one policy mean during this year, only one person who is of age 25 will die. Okay, so what is the probability that one person will die and the company will pay the insurance claim to the family of that member? So you can find it out. How you will find it out? So definitely, if this is Poisson probability distribution, then you are required to use the average value mu. So what will be mu in this case?
Point.
This is this is self-review 6-6, self-review 6-6, and mu in this case will equal point. Basically, it is NP. NP. So what is N in this case? 4,000. And what is P? Probability of success. 0.0002. 3 times 0 and then 2. So simply multiply. What is the answer? Quickly, boys. We don't have time that much. So simply multiply. So you
Sir,
must have your calculator.
0.8.
0.8.
0.8, sir.
0.8. 0.8.
8.
So 0.8 is the answer. No, yes, 0.8 is the average value. Fine. Now the question is, what is the probability? They will pay on exactly one policy. So for this, uh, let me move to the next page. Probability of X is equal to 1, exactly 1. They are going to pay the claim against the demise of or death of one person. So mu power X, what is mu? 0.8. And power X means you will take 1 because small x is equal to 1. Then E and raised to the power minus mu, so 0.8 divided by x factorial. So x is 1, so 1 factorial. Let us see what is the answer. So all of you must be able to solve this situation
1.7804.
calculator on your calculator. So you should be able to use your own calculators. Yes, boy.
1.7804.
How it is possible? Probability could not exceed 1.
So
So
sorry,
you
minus
so what are you doing? Probability could not exceed 1. It could not
point
be less than 0.
point
Yes.
three five
Point
3594.
95. 0.3595 when you will round it off. Fine. Then come to the other questions. In a Poisson distribution, mu is equal to zero point 0.4. So mu is given. What is the probability that x is equal to 0? So you will simply write down x is equal to 0 and mu power 0 e power minus zero point 0.4 divided by 0 factorial. What is the probability that x is greater than 0? What is the probability that x is greater than 0? So in this case, how will you find it out? Yes, boy. Greater than 0.
X1 रखें.
Let me write down. It was 31 or 32? 33. Question number 31? Yes, 31. 31. Yes. Probability of x is equal to 0. You can find it out. And what is the probability that x is greater than 0? X is greater than 0. So 1 minus probability of x is equal to
0.
0. Okay, so because this is the only possibility. If x is greater than 0 and you are going to use the complement rule, so the value that is less than, you can say, greater than 0, so 1, 2, 3, 4, 5, 6 up to infinity will be there, and less than this 0. So 1 minus, if you will subtract, it means in this interval 0 is not there. So if you subtract this 0 from 1, you will have the probability. So in first part, when you will calculate probability of x is equal to 0, whatever value you will have in that part, you will use that or substitute that value over here and subtract that from 1. You will have the answer. So I'm sure that you can do it.
Yes, sir.
In a Poisson distribution, mu is equal to 4. So again, mu is given, and it has been stated that it is Poisson distribution. So you will recall the Poisson probability distribution formula. What is the probability that x is equal to 2? You can find it out. Simply substitute the value probability x is equal to 2 and substitute the remaining values in the formula. All values are there. Simply you will be able to calculate the answer. So what is the probability that x is less than or equal to 2? X is less than or equal to 2. How will you find it out? Probability of x less than or equal to 2. Okay. So you can see that if you are going to use the strategy in which 0, 1, and 2 is there, that is more appropriate as compared to the other strategy where we use the complement rule. Because if you are going to use the complement rule, then there will be infinite, you can say, terms will be there. Okay, so there are basically two strategies. If you are going to use the complement rule, then you can write it out as probability of x greater than 2. So now when it is greater than 2, then 3, 4, 5, 6 up to infinity will be there. So many terms will be there and you are not able to calculate that situation. So therefore, this is not the appropriate strategy. The appropriate strategy will be, you will write it down as x is equal to 0. This is the first term, that is less than 2, plus probability of x is equal to 1, and then plus probability of x is equal to 2. So
Yes.
these three terms will be there. Right? So now you will solve it one by one. What is the value for px is equal to 0? You will find it out. Then for 1, and then for 2, and then you will add all these three to have the answer for this. Fine, I'm sure that you can do it.
Yes, sir, we can.
Okay. Then there is a situation that is part C of this question, and in that the probability that x is greater than 2, this is required. So in this situation, if you are going to use this strategy that I have used over here in this situation, so then probability of x is equal to 3, 4, 5, 6, 7 up to infinity, you would have to write down. So that is not possible. So therefore, we will use the complement rule, and in this case, probability of x will equal probability of x greater than 2 will equal probability of x less than or equal to 2. So now all three conditions will be there. So this is the scenario when x is greater than 2. The remaining two situations that are possible are less than 2 or equal to 2. So less than and equal to 2, you will consider in this side, right hand side. So all three conditions will met. This is greater than, less than, equal to. There is no fourth condition. There is no, you can say, the fourth condition. We have always only three situations or conditions that something is equal to or greater than or less. So this is the appropriate way. Why? Because in this case, you would simply have to write down three terms. 1 minus probability of x is equal to 0. 0 is there, yes. Plus probability of x is equal to 1. Plus probability of x is equal to 2. So all three possibilities you will write down over here. And if you see this situation, you have already calculated the probabilities for probability of x less than equal to 2. So you will simply substitute this value over here and you will subtract that value from 1. You will have the answer for this. Clear?
Yes, sir.
Then question number 33 is there. And let us try solving this. Miss Burjan is a loan officer at Coast Bank and Trust. From her years of experience, she estimates that the probability is 0.025 that an applicant will not be able to repay his or her installment loan. Last month, she made 40 loans. Okay, so now the question is, what is the probability that 3 loans will be defaulted? Okay, what is the probability that at least 3 loans will be defaulted? So you can see that she estimates using his experience. So she's an experienced lady, and she knows that the probability that an applicant will not be able to repay, I mean, he will remain defaulter, he will be defaulter. So somebody will default. The probability for that is 0.025. Okay, and she is going to give 40 loans. So therefore, you are able to calculate mu from here, because you know mu is equal to np. So n is given, and probability of success, that is in this case is defaulting alone. So you will simply multiply 0.025 with 40. So this will give you the answer, and that value will be the average. Okay, and then you will find out different probabilities, whatever is required. So yes, so what is mu in this case?
10, sir.
10.
Yes, sir.
Calculate it again. 0.025 multiplied by 40.
Yes, sir. 10.
0.025 multiplied by 40.
Okay, 0.025 multiplied by 40. 1.
Yes. So you were doing it wrong, because I think you were multiplying it with 0.25.
Yes, sir.
So the answer is 1. So I mean, mu is equal to 1 in this case. Mu is equal to 1. And what is required? What is the probability that 3 loans will be defaulted? 3 loans will be defaulted. So you will write down probability of x is equal to 3. Sorry, x is equal to 3, and you will substitute the values in the formula. Mu 1 power 3 mu power x, then e power minus 1, this is minus mu, divided by x factorial, so 3 factorial. So see what is the answer.
0.06.
Sorry,
0.0613.
0.0613. 0.0613. So this is the answer, right? And if you see the next part, what is there? What is the probability that at least 3 loans will be defaulted? At least. So as the word at least is there, so you will use this sign, probability of x greater than or equal to 3. Okay. So now, definitely, if you use the strategy that is as it is, greater than or equal to, so probability of x is equal to 3, 4, 5, 6, up to infinity will be there. So you will use the complement rule. So probability of x less than 3. So you can see it was greater than or equal to. Greater than or equal to. So the third possibility was less than. The third possibility is x is less than 3. So I'm writing down that third possibility over there. And if you see the previous example, this one possibility was there. So therefore, I use the remaining 2 possibilities on right hand side. Okay. So you should be very attentive in writing down these notations, because otherwise, if you are going to use the wrong notations, then answer will not be correct. So now you can write down the terms in this way. The terms that are less than 3, probability of x is equal to 0. This is first term, plus probability of x is equal to 1. Probability of x is equal to 2. And 3 will not be there because x is less than 3. So 3 is not there in this. So you will stop over here, 0, 1, 2. So you will find out the probabilities for these 3, and whatever will be the answer, you will subtract that answer from 1. So you will have the required probability in that case. And this way you will have the required probability. Now let us see question number 34. Automobiles arrive at Elkhart exit of the Indiana Toll Road at the rate of 2 per minute. The distribution of arrivals approximates a Poisson distribution. So this information is given. So I mean, mu is given, that is 2 minutes, and Poisson distribution, the information regarding the distribution type is also given. So now what is required? What is the probability that no automobiles arrive in a particular time? So probability of x is equal to 0, you will calculate. Probability of x is equal to 0. Mu is 2. How will you find it out? This is 34. 34. Example 34. So probability of X, no vehicle arrived at the toll plaza, you can say. So X is equal to 0. No automobile arrived. X is equal to 0. And Poisson distribution, so mu is required, mu is given 2. Mu power X, 2 power 0. And then multiply by e power minus mu, so minus 2, divided by x factorial, so 0 factorial. So 2 power 0, 1, 0 factorial 1, you simply have to have the value for e power minus 2. Yes, boy.
0.1353.
0.1350.
3.
5-3.
0, I mean, because you're using the decimal points up to 4 position. Up to 4 decimal points, you are going to give the figure. So therefore, 0.1350. Similarly, if you see the next question, what is the probability that at least one automobile arrives during a particular minute? So in this case, how will you solve it? At least one automobile. So probability of X greater than equal to 1 at least. So you will use the complement rule, probability of X less than 1. So less than 1 is 1 minus probability of X is equal to 0. So whatever you have calculated in the first step, first part, you will simply substitute this value over here and you will have the answer. So 1 minus 0.1350. What is the answer?
0.8646.
8646. So this is the answer. Okay. Now come to the next question. It is estimated that 0.5% of the callers to the customer service department of Dell Incorporation will receive a busy signal. What is the probability that today's 1200 callers, at least 5 receive a busy signal? So you can see that the probability of success is so small and the number of callers in this case, or sample size in this case, is so large. So therefore, Poisson probability distribution formula will be used. And you simply have to write down the required information in form of quotations. And how will you see how you will write it down? Let us see. This is question number 35. Fine. So what is mu in this case? What is mu in this case? Read the question. What is mu in this case? It is estimated that 0.5% of the callers. Okay, so this is probability of success, small p. And this is n, sample size 1200. So np, mu is equal to np. What is n? 1200. What is p? 0.5%. So 0.5 divided by 100. What is the answer? 0.5% means 0.5 divided by 100. What is that?
0.00.
5 multiplied by 10 raised to power minus 3.
0.005.
0.005. 0.005 is your probability of success. So now multiply these two. See what is the answer.
6.
6 is your average. Okay, so you can say that on average, 6 calls are there that have busy signal. We're talking about busy signal. So 6 callers are there who, on average, receive a busy signal when they call. Okay, so now mu is there. So now what is required? At least 5 received a busy signal. At least 5 received a busy signal. At least 5. So how will you write it down? Probability of x
greater than equal to 5.
greater than or equal to
5.
5. So definitely now if you're going to take into your account this rule that is given over here in this term, so you will start writing from probability of x is equal to 5, 6, 7 up to 1200. So we are not going to use that lengthy route. We will use the other route, and that is probability of x less than 5. So two possibilities are there. We'll write down the third possibility. And now in this, which terms will be included? X is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, and x is equal to 4. So up to 4 you will write down the terms, and then you will use the binomial probability distribution formula for all. So I'm just going to write down the first term. The first term will be probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4. So you will use for each term the Poisson probability distribution formula, and you can take help of, if you see, probability distribution table. But if 0.005 is not there, then that would not help you. You will use your calculator. So you will calculate all these probabilities separately, and then you will add all these probabilities, and whatever will be the answer, you will subtract that answer from 1. You will have the answer for the required probability, right? So it is not difficult. In the past, schools in the Los Angeles County have closed on average for 3 days each year. On average, so 3 is given. So what is this 3? This is mu. What is the probability that schools in Los Angeles County will close for 4 days next year? For 4 days next year. So it means probability of x is equal to 4 is required. Mu is given, that is 3. So you will simply substitute the values in the formula to have the answer. Is it clear?
Yes, sir.
So you can find it out. So now this chapter is over. Inshallah, in the next class, we will start continuous probability distribution. And in that, we will try to learn that what is the uniform probability distribution, normal probability distribution. And if we found time, then we will talk about exponential probability distribution. That are the types of, basically these 3 are the types of continuous probability distribution. So up till now, we have covered the discrete probability distribution formula. So Poisson, hypergeometric, binomial, these are all types of discrete probability distribution. Fine.
Yes, sir.
So this is all for today. Thank you very much.
Thank you, sir.